Welcome back to Ratty Tutorials. In this part we're going to go over the hardware integration. We're going to do everything hardware related. So we're going to jump in and we're going to look at how my cell phone interacts with the Raspberry Pi, but most importantly how this connects to the MSP430 microcontroller, and then how this controls the servo, which opens up and clicks the garage door. So I'm going to show you how all these wires connect together and what that looks like. So we're going to learn about breadboards, how to connect the LED to the MSP430, and then, let's talk about various solutions we can open up the garage door. So for the garage door, there's about 3 different ways to do it. One is you can get a servo to actually click the button on that, and that's the one that I'm going to be showing. But you can also do several other ones using relays or anything. But if you have interest in, say, oh shoot, I don't have a servo on hand, how else can I open it? Well, add a comment in this video and I will come out with another video showing you how to do that with maybe a relay or some other method. Then we're going to implement MOSFET. We're going to teach you how to power on and off the servo, and so you can't use a traditional GPIO pin for that. And then just show you how UART is connected from the Raspberry Pi to the MSP430. Hey, if you have any questions, please post them to my forum. I don't have any questions yet. I'll show you a website right here, forums.rattytutorials.com. You can jump on to here and just make a user account and then post any questions. They come directly to my phone and I will reply to you as soon as possible. So, alright, well, let's jump into it.
So right now what we're going to be going over is this project as a whole. And what it does is we have our garage door opener right here, and I have crafted this fancy recyclable device which has a stepper motor, sorry, not a stepper, a servo right here, and the servo moves the knife up and down to click my garage door button open. Now there are about 3 or 4 different ways that you could really open up your garage door. This is just one method using a servo. I could make more tutorials over other ways. If you post comments and have interest that, oh, maybe I don't have a garage door opener, I need to find another method, then let me know and I can make another video. But right here we have the MSP430 breadboard. I'll explain that a little bit, and then the Raspberry Pi. And end goal is when I click the button on my phone, watch the servo move and clicks the button. Oh, did you see it? So I just clicked a button on my phone which transmitted over Wi-Fi and made it move. Check it out. Just like that, garage door open. Let's break it down.
So let's jump into the schematic to see how this all looks in the hardware realm. So this is the schematic. Here we go. We got our Raspberry Pi representation here, microcontroller, and then all this confusing mess. But let's break it down and go through it. So coming off of our Raspberry Pi, this is what's powering everything, okay? So you've got 3.3 volts, which is going to go to power your LED and then your servo. Then UART transmit from your Raspberry Pi is going to go and connect to UART receive on the MSP430 microcontroller, which is P1.1. And you got ground. Everything needs to be grounded. So Raspberry Pi is grounded, microcontroller is grounded. And then coming off of here, the easy one, P1.7 is going to our status LED. So this is going to provide 3.3 volts, high or low. You can turn the LED on and off. And then 1K resistor. And then we're going to go for our P1.4, which is what's going to power the MOSFET, which is like a gate turning on and off to turn on the servo. And so we got our 100 kilo ohm resistor right here called the pull down resistor. So essentially when you turn this on and off, it'll turn the servo on and off. Alright, and then P2.1 is the signal going to the servo, which is essentially going to tell it where to be placed. We're going to send it through a 1 kilo ohm resistor right here, and then servo's connected high and low.
Alright, so let's go over this MOSFET that we saw in the schematic. So again, the idea is that it's going to be able to turn the servo motor on and off. So this is how I organize most of my parts. Little fishing tackle box, and then I print out my labels. So we're going to pull out my N-channel MOSFET right here. It's a BS170. You can search for that online, purchase it. There's all kinds of N-channel MOSFETs, but that's what you're looking for. So I have a 2.1 volt gate, which means I can turn this switch on and off with 3.3 volts, no problem. And then resistance, and then it's going to be able to source 0.5 amps, which should be plenty for my servo. Alright. So we got this guy, and I'll pull up a schematic to show you that at the top wire we have the drain, and then the gate, and then the source at the bottom. Let's go ahead and put it down. Anywhere is fine. Just like that. Okay. And generally whenever I'm building breadboards out, I like to run wires across the bottom just so that I can connect my power on both sides. So let's go ahead and do that. I'm going to grab one of my jumper wires. Strip it off. Just like that. We're going to run from red to red down here at the bottom. We'll do the same for black. Bottom to bottom like that. Okay, so now we have power connected down this line, which is helpful later on. Alright, so I always like to do source first, and my source for this N-channel MOSFET is connected directly to ground. So make myself a little jumper wire for ground. We'll connect that over, maybe if it's long enough. Okay. Then we can connect our LED. So that's going to be drain. I'm draining it through the LED to the battery. So we'll do through the resistor. This is a 1 kilo ohm resistor. That's going to be the top wire. Through the LED. And then this side of the LED is going to go to power, so I'll go ahead and do that over here like that to make it easy. So that's going to it's going to be 3.3 volts right here. Okay, so then all we have left is the gate. So the gate is going to go, this is a 100 kilo ohm resistor, and the purpose of this is called for a pull down resistor. So I'm going to connect from the gate to ground. So essentially I'm pulling this down, I'm making it 0 volts at the gate, and so then whenever I apply 3.3 volts at the gate, it will turn it off, and then if I take power off, the resistor will force it down to 0 volts. It's kind of a safety precaution, you could say. Okay, so let's use jumper wires now to connect it up. So I'm going to set a link in to my favorite jumper wires from Amazon. But you get 3 different types of jumper wires. Here you have male to male, female to female, and then male to female. And this kind of gives you the most flexibility in all of your projects. They're really easy to use. You just rip them off and plug them in. So we're going to need one for ground, power, and then for my signal. So I'm going to connect these directly to my other breadboard, which is 3.3 volts coming from my MSP430. So I just ripped these off, and I've got brown, we'll call brown signal, and then I have power and ground and brown. So I'm going to connect power up here, you can see that, and then I'm going to connect it onto my MSP430, which you cannot see, and hope it works. Okay, so everything's connected. Then we have my signal, which I will just use male to male for that. So now I plug it into my gate, which is the middle one, and then if I plug this into 3.3 volts power, it should turn it on. Let's hope, cross your fingers. Boom, turned on. It's not very bright, but I could use a smaller resistor right here to make it brighter. Alright, so this is to teach you the purpose of a MOSFET. So essentially, when you're using your microcontrollers to turn a pin on and off, it can only has enough power to maybe turn on an LED like this. But if you're trying to power big motors like a servo motor or something else, you can't power a servo motor from your itty bitty, input output pins, GPIOs right here. They're not powerful enough to power a motor. So you really need a MOSFET. So right now I can run this line to my GPIO, general purpose input output pin, on a microcontroller, and I can turn this on and off no problem. It doesn't take any current at all. And so then that is turning this MOSFET, which acts as a switch, honestly. It's just like connecting two wires together. It's a little switch, but you can control it electronically. So now I can power big motors with my little bitty microcontroller. So hopefully the schematic gave you enough details about how all this is connected, but I'm going to go through a quick rundown of like what's connected where, but please reference the schematic because this is going to be really confusing. So from the Raspberry Pi, you can see that all we have is ground and UART transmit coming off of here. So that's just two pins coming to here, sending that hash over, and then this microcontroller is the one making the decision if it's going to be good or bad. And the reason that we're doing this is really because this Raspberry Pi, it's a computer. It can be hacked very easily. And so if a hacker gains access to this, they're still not going to be able to open up your garage door very easily because all they have are these two pins coming to this microcontroller out here. So it's kind of a security practice. Alright, so these are going directly to the MSP430, and then everything coming off onto this breadboard is an LED, and then the MOSFET, which is powering this servo to actually click the garage door button. So we already went over how to do this MOSFET right here. We got that, and I have the gate pin coming back onto the MSP430, and then I have this other signal right here coming to this LED right here. You could call it a status LED, and it's just to tell me if I received a hash and then if I accepted the hash or rejected it. But other than that, I mean, that's really it. We got an LED, a MOSFET, and then UART coming. So it's very simple. A bunch of wires going everywhere, but please reference the schematics and it'll hopefully make sense. Let's go over this wooden contraption right quick. If you ever want to build this, then just here's a quick overview of how it functions. So we have just this really skinny board down here which allows me to clip this on and off. So I'm essentially not modifying this. I can just take it off and put it back in your mom's car or something like that if she doesn't like you working on projects like this. But then got a knife right here, 2x4 board I cut off. I drilled pilot holes through these first before nailing them in, otherwise you'd split the plastic, so drill a hole through it first, then put the nail in. And then we have our servo motor down here screwed into the board, and then for this I just used a thick copper wire. you could find laying around, and then bent the edges and then plugged them into the holes. And then this is a servo motor you can find, goes up and down like that. So then for the wiring, of course we've got ground 5 volts, or is it 3.3? Yeah, it's actually 3.3 volts going through the MOSFET, and then we have signal right here, which essentially tells the servo where to be. And then you have a resistor going from signal to my MSP430 microcontroller. So let's see it all operate one more time. Like that. See how that works. Just like that. Moves the knife, clicks the garage door, and opens it.